Now action with metal carbonates and bicarbonates. What do you mean by carbonates and bicarbonates? Carbonates are which are having the, we will talk about the radical. The carbonates are, here it should be R, carbonates are CO3 2 minus and bicarbonate radical is HCO3 minus. Okay, when this plus minus charge is there, that will get balanced when any metal reacts with it. Like see, when zinc reacts with this, so suppose we are getting zinc carbonate, so Zn2 plus CO3 2 minus, so we are getting ZnCO3. Similarly here sodium Na plus and HCO3 minus, so you are getting NaHCO3, like that. Okay, so metal carbonates and metal bicarbonates are reacting. How it is reacting, let's see. All metal carbonates and bicarbonates react with acid to give corresponding salt, carbon dioxide and water. Okay, the reaction can be summarized. The skeletal reaction, metal carbonate or hydrogen carbonate means bicarbonate, reacts with acid to give salt, carbon dioxide and water. Okay, now both metal carbonates and bicarbonates with acid to evolve carbon dioxide to form salt. Like calcium carbonate, suppose for example is taken, reacts with HCl to give calcium chloride, water and carbon dioxide. Okay, same way sodium bicarbonate is also taken, so reacts with H2SO4 sulfuric acid, you are getting sodium sulfate salt plus water plus carbon dioxide. So bicarbonate is also called a hydrogen carbonate. Why? Because in the formula there is a hydrogen present and there is a carbonate CO3 group is also there, so that is called bicarbonate or hydrogen carbonate. Okay, now take small amount of calcium carbonate in a test tube to add this dilute HCl. Okay, so two test tubes, we are labeling them A and B, and take about 0.5 gram of sodium carbonate in test tube A and 0.5 gram of sodium bicarbonate in a test tube B. Two test tubes are taken. In one test tube what we have taken? We have taken sodium carbonate. Another test tube we have taken sodium bicarbonate 0.5 gram. Add 2 ml of dilute sulfuric acid in both the test tubes. We to check, to compare what is forming. Now pass the gas produced in each case through lime water. Now whatever gas is produced, that carbon dioxide gas is produced, that gas will be passed to the lime water. Lime water is calcium hydroxide solution. If lime water turns milky, means carbon dioxide is produced. If it does not turn milky, means it is not produced, like this. So let's see here, dilute HCl, brisk effervescence. Brisk effervescence means carbon dioxide gas is bubbling up. Calcium carbonate is treated with acid. Whenever calcium carbonate treated with acid, it will liberate carbon dioxide from it. The CaCO3 will break as CO2 and H2O will also form. Okay, CaO will form. Lime water turns milky. Now what is happening? The gas which is bubbling, carbon dioxide, is passed through lime water. So lime water will be colorless, but as it touch to the carbon dioxide, it will start turning milky color. Okay, so lime water will turn milky. It means to demonstrate that carbon dioxide gas is liberated when calcium carbonate reacts with dilute HCl. Okay, we have seen the reaction just now. Now reaction will immediately start and accompanied by brisk effervescence. Brisk effervescence means like carbonated drink bottle, when you open, the bubbles will start coming, like that only. That is called brisk effervescence. This shows that a certain gas has been liberated. When the gas is bubbled through lime water, it immediately becomes milky, and this shows that gas liberated is carbon dioxide. The liberated carbon dioxide we have checked by this method. So lime water reacts with carbon dioxide, you are getting a milky color precipitate because of calcium carbonate formation. So the milkiness disappears when the gas is bubbled in excess through the same solution. When more gas is added into same solution, what will happen? The milky color will disappear and you are getting a soluble calcium bicarbonate here. Okay. Now calcium carbonate is insoluble in water, while calcium bicarbonate is water soluble. Okay, so carbon dioxide gas is evolved in in each case, which turns lime water milky. Now sodium carbonate reacts with sulfuric acid, you are getting sodium sulfate, water, carbon dioxide. Then sodium bicarbonate reacts with sulfuric acid, you get sodium sulfate, water and carbon dioxide. Now limestone, chalk and marble are different form of calcium carbonate only. Okay. Now all metal carbonates and hydrogen carbonates reacts with acids to give corresponding salt, water and carbon dioxide. Okay, like calcium carbonate when reacts with HCl, you are getting calcium chloride, water and carbon dioxide. Like eggshell also contains calcium carbonate as the main constituent, hence they react with acid. Okay, and similarly you can see the experiment, chemical properties of acid. If excess carbon dioxide gas is passed through lime water, then the white PPT form first dissolved due to formation of soluble salt, calcium hydrogen carbonate, and the solution becomes clear again. Now what we observed here, we have calcium hydroxide reacts with, calcium hydroxide was our lime water, reacts with carbon dioxide, you get white color precipitate calcium carbonate. Now we have more carbon dioxide we passed in that lime water only, so what happens, it is getting dissolved and calcium bicarbonate is obtained, which is soluble in water. So clear lime water is there here. When carbon dioxide gas is passed through lime water, it turns milky. Now if carbon dioxide is passed for longer time, the milkiness disappears. Why? Because calcium bicarbonate, which is in soluble form, which is obtained. Okay. Now reaction of acids and bases with each other. Now acid and base reacts means that is called neutralization reaction. We are getting salt and water. So when acids and base reacts, when a solution of acid is treated with solution of base, salt and water is obtained, and the product, this reaction is called neutralization reaction, because salt is a neutral product, we are getting it. Okay. A neutralization reaction can be written as acid plus base gives salt plus water. If we can write one reaction also like this, we have base sodium hydroxide, we have acid hydrochloric acid, we are getting salt sodium chloride, and we are getting water. Okay. So this is called neutralization reaction. The reaction is called neutralization because the salt which is formed is generally neutral towards the litmus. When the litmus test is done, it is not showing any color change. The neutralization may be defined as the reaction between acid and base present in aqueous solution to give salt and water. Okay. Like we have experiment here, reaction of acids and base with each other. So what kind of reaction? Aim is to study the reaction between acids and base, neutralization reaction. What do you mean by neutralization? When equal number of H plus ions get neutralized with equal number of OH minus ion, or 1 mole of any acid gets neutralized by 1 mole of any base. Okay, that is called neutralization reaction. You get salt and water. Okay. Now take 2 ml of dilute NaOH solution in a test tube, add 2 drops of phenolphthalein. Now we have studied indicators. Indicators are the chemical substance which gives specific color in specific medium. So we have 2 indicators for your focus. One is phenolphthalein and one is methyl orange. Phenolphthalein gives pink color in basic medium. Methyl orange gives pink color in acidic medium. Okay. So if we take in a test tube 2 ml means few drops of NaOH solution, we add phenolphthalein. NaOH solution is colorless solution. As we add phenolphthalein, it will be, solution will start looking pink color. Okay. Now note the color of the solution. As we add phenolphthalein, the color of the solution will be pink. Second is add dilute HCl to solution, above solution drop by drop. In solution NaOH, what is there in a test tube? Test tube you have NaOH here and you added phenolphthalein. When you add this, okay, NaOH and phenolphthalein, your solution looks pink. Then in that, if you try to add HCl in this pink color solution, so what will happen? Pink color will disappear. Note the change in color after adding HCl. Now see, note the change in color, it is pink in color. Now add dilute HCl to this drop by drop, so pink color disappears. Okay. Now note the change in color of the reaction mixture. You have colorless, no color. Why? Because you are adding HCl in that. Now add few drops of NaOH again to above mixture. As you add NaOH, it will start looking pink. As the equal number of NaOH and HCl is obtained in the solution, the indicator will not show. In that case, neutralization reaction will take place, and phenolphthalein, when HCl is there, phenolphthalein will not show any color. Colorless solution will be obtained. Okay. So let's see here. On adding phenolphthalein to sodium hydroxide solution, the color becomes pink. On adding HCl solution, hydrochloric acid dropwise, finally the pink color disappears and solution again colorless. Okay. On adding NaOH, again when you add NaOH, the pink color reappears, because pink color in basic medium, it shows, phenolphthalein shows pink color in basic medium. So medium will be again basic if you add sodium hydroxide. So again pink color reappears like that. Okay. Then we are proving it, pink color is obtained in, phenolphthalein gives pink color in basic medium. Now acids and base together react to form salt and water. This is only called neutralization reaction. What is this reaction called? Neutralization reaction, when acid and base combines to give salt and water. For example, few reactions are there. Nitric acid, HNO3, reacts with potassium hydroxide, you get potassium nitrate and water. Potassium nitrate is a salt and water. Now hydrochloric acid reacts with ammonium hydroxide, you are getting ammonium chloride and H2O. So this is acid, reacts with base, salt and water. Here this is acid, reacts with base, here salt and water. Okay. So these two are acids, these two are base, these two are salt, and this is water only. Okay. So what is this reaction? These reactions are called neutralization reaction. Clear? Next we are seeing action with metal oxide. What will happen when metal oxide reacts with them? Now metal oxide reacts with any acid, you always get salt and water. Okay. So acid reacts with metal oxide to give salt and water. These reactions are mostly carried on heating. For example, any metal oxide reacts, like for example zinc oxide reacts with HCl, you are getting metal chloride, zinc chloride and water. Now if any sulfuric acid is reacting, so there is a sulfate group. So what will happen? You get a salt with sulfate, like magnesium sulfate, then water. Salt and water is obtained. Now experiment is there. In one test tube they are taking copper oxide, reaction between copper oxide, and another test tube they are adding dilute HCl in it. Similar kind of reaction will come here. Copper oxide reacts with HCl. What we will get? We will get copper chloride and water, same way. Okay. So next we are seeing here, in a tube take a small amount of copper oxide, or it is called cupric oxide. This add dilute HCl dropwise with slow stirring. We can stir it here, copper oxide is there, HCl is added. Note the color of the solution. Okay. What is the color of the solution? Because copper chloride is obtained, so bluish green color is obtained. Okay. So the black color changes to green due to the formation of copper chloride. What is the color change? Bluish green due to formation of copper chloride, or we can call it another name as cupric chloride. Okay. So copper oxide reacts with HCl, you are getting cupric chloride and water. Now oxides of metals are generally basic in nature. Okay. So now we can see here metal oxides with the acids to form salt and water. Whenever metal oxide reacts with acid, any acid, HCl or sulfuric acid, you are getting a respective salt and water. Now see, for example, metal oxide, copper oxide reacts with HCl, you are getting copper chloride and water. If copper oxide reacts with sulfuric acid, you are getting copper sulfate and water. Like that here also, calcium oxide, here this shows the metal oxides are basic in nature. Why? Because when they reacts with any acid, they are giving salt and water. So acid reacts with base, you are getting salt and water. So when we are getting metallic oxide, they are basic in nature, so you are getting salt and water. So calcium oxide gives calcium chloride and water. Magnesium oxide reacts with sulfuric acid, you are getting magnesium sulfate and water. Again neutralization reaction is taking place.